Right, it's visible, right? Cool. Okay guys, thank you. So we can start this session. So from the poll, I can see that whatever you answered in the poll is, so a lot of you mentioned that you know how to find the factors of a given number, and eventually if you know how to find the factors of a given number, you can count them, you can add them up, and you can also find whether the given number is prime or not, right? But the next two questions I answered, only a few of you have said that you know this, right? So basically this is an optimized logic. We can use the square root of n logic to find the factors, as well as you can use the same logic to check whether the given number is prime or not when the constraints are tight. Constraints are tight means if the number can go up to 10 power 18, so which doesn't fit under integer data type, in that cases you may get something called as a time limit error in the problems you are solving, because your logic takes too much time even for the computer to compute it, right? In that case you need something called as optimization. So these concepts, finding factors using square root of n logic, helps you reduce the running time of the code, right? So first let us see where you can use this. Before that, a couple of days ago, so I sent you this problem from LeetCode. So this is called as perfect number. How many of you solved this? If you solve this, give a thumbs up symbol to this problems link. Here is the problem link. If you solved it, give a thumbs up symbol to it. Otherwise, we will solve it today. Okay, so out of 70 members, 30 members have responded. Okay, these 30 or 31 members said that you solved it, right? Okay, so for the rest of the people, I will explain this problem. Not only that, I will explain you one approach that will be very much useful to you to solve a lot of prime and factor related problems without getting time limit error. Okay, so first let us look at the problem description. So the problem itself is not that difficult, right? You can see the problem states that a perfect number is a positive integer that is equal to the sum of its positive divisors excluding the number, right? So if you take a number like 28, what they're basically saying is, for any given number, so you need to find out factors. Sometimes factors are also called as divisors, right? Because they divide the number. We call them as divisors because they divide this number. You need to find out the factors, and we all know that the factors of 28 is 1, 2, and then 4, 4 sevens is 28, and then 7 fours is 28, 14, and 20. Now what you need to do is, you need to find out the sum of these factors, but you should not include the given number, which means every number is a factor for itself, we know that, right? But we should not include this number in the summation we are making. So you need to make the summation only using the factors that doesn't include the number itself. So which means you need to add 1 plus 2 plus 4 plus 7 plus 4. Now let's add them together. This is 7 plus 3, 10 plus 4, 14, right? And 14 plus 14, 20. Now you can see, if you perform this operation, you need to perform the summation of all the factors excluding the number. The result is nothing but the given number. See, the actual number is 28, right? And this result is also 28. Now this kind of numbers are called as perfect numbers. Now this might not be true for all the numbers. For instance, if you take 10, we know factors of 10, right? That is 1 to 5. Okay, so factors of 10 is 1 to 5, 10. Now if you add all the factors except 10, what would that be? That's 1 plus 2 plus 5. That is 8. Now you can see, if you apply the same logic on 10, it's not giving you 10 again, it's giving 8. So you cannot call 10 as perfect. So 10 is not a perfect number. But 28 is a perfect number. Okay. Do you guys know any other perfect numbers? So one perfect number is given in the program, right? Can you tell me one more perfect number? So one perfect number is 28. Do you know any other? No? Ah, yes. 496 is perfect. 6 is perfect. Yeah. 6 is also perfect number. That's correct. Good. Now, I hope I gave you enough explanation, guys. So if you understood my explanation, could you just put up a message in the chat box that I understood? Or you can give them some symbols like thumbs up symbols or whatever. Okay, so first, for every question we read, let us make sure that we understood the question first, and then we will go with the approach. Now, let us go with the approach. And as you already know, the approach is not that big for some intermediate coder, right? So the approach is pretty simple. All you need to do is to find out the sum of the factors of the given number, excluding that number, right? So first of all, let us ask the basic question that we learned in the first semester. How do we even compute the factors of a given number, right? So the very first logic that you will learn in your first year is, in order to find the factors of a given number, we follow something called as intuition. Intuition means we try to algorithmically write the code for what our brain does to find the factors of a number, right? For instance, if you try to take a number like 10, and if I ask you, can you tell me what are the factors of 10? Now you would simply say that, sir, factors of 10 are 1, 2, 5, 10. But if I ask you a question, why did you not tell 3? Like you said only 1, 2, 5, 10, right? So why did you not tell 3? And immediately you will answer that, sir, I know how to find the factor of a number. For instance, if I take 3, if I have to check whether this is a factor of 10 or not, all I need to do is perform 10 mod 3, right? So 10 mod 3 means you are trying to check what is the remainder when 3 divides 10. So you know that 3 goes into 10 3 times, right? 3 into 3, 9, and the remainder is 1. See, remainder is not 0. If remainder is not 0, it's not a factor. That's definitely an explanation that is fair enough. So for instance, if you take this 2, sir, I tried to, when I tried to, 10 mod 2, 2 goes into 10 for 5 times, 2 into 5, 10, and the remainder is 0. See, whichever the number is giving 0 as the remainder when it divides 10, those are the factors, right? But the question you have to ask your brain is, the reason you skipped 3 is because you checked 3 also. Am I correct, guys? I mean, without checking 3, you cannot come to the conclusion that 3 is not a factor of 10, right? So you may agree that, you may argue that, no, I didn't, but internally your brain does this. Is it correct, guys? Do you agree that your brain internally, I mean, in a lightning speed, yes, it happens at a lightning speed, you will definitely check it, right? Yes. So from this, we frame our logic, right? What is the logic? The logic is, it doesn't matter whichever the number is given. For instance, the number can be 10, the number can be 24, or the number can be a perfect number like 28. It doesn't matter. I have one approach. What is that approach? Generate all the numbers from 1 to n. So we can call these numbers as n, right? So while generating, check if the current number divides n with the remainder being 0. Then it's a factor. So in other words, if you take a number like 10, the idea is to somehow generate all the numbers from 1 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But while generating, you will check, hey, now I have 1 with me, right? Is this 1 dividing 10? How do you check it? Simply put 10 mod 1. Is it 0? Yes, it is 0. If it is 0, keep 1 in the picture, which means it's a factor, right? You do the same. Now I will check 2. Is 2 dividing 10? Yes. then keep it in the page. Is 3 dividing 10? No. 4 dividing 10? No. So take out 4. Is 5 dividing 10? Yes. 6, 7, 8, 9? No. 10? Yes. This is how for any number you try to find the factors. This is what we learned, right, in the first year. Now, doing this is not enough for this problem, because in this problem there is a little trick. The trick is they don't want you to include the given number. For example, the factors of 28 include 28 also, but you don't want this. You only want the factors up to 14, right? Now in that case, you may decide that instead of going up to 10, I will stop at 9. Because if I don't even visit 10, then it won't be a factor, right? So 9, however, is not a factor. So my factors are only 1 to 5. This is good, right? So what is our logic now? Just try to find the factors. While finding the factors, sum them up. And after summing the factors, let us compare, or let us try to compare the factor sum with the given number. If they are same, then it's perfect. Otherwise not. Is the approach clear, guys? Did you understand the approach? Yes, right? Okay. So now we can actually go ahead and try to implement this. So I'm implementing it in Python. So you can implement it in any language. So the reason in the first ever class, not in the first class, I mean in the second class, I explained you the concepts of functions is, I told you already, this is not a beginner class. So I'm expecting you to have the knowledge on, at least at basic level, strings, functions, arrays, what are the basic concepts that are present, right? So you can see in Python, the code in LeetCode by default is given in the form of classes. So there is a class and there is a method inside, right? So actually this should be called as a function. Just because it's inside a class, we need to use the term method. Okay. Now, how the input is being read and how the input is being passed, how the object of this class is created, and through that object, how this particular method is called is not your headache. Okay. Please note that when you're solving problems in LeetCode or in any other platform for that matter, like CodeChef, you can start writing the code from scratch. So there is no such thing like it. But in GFG and LeetCode, this is the structure, right? So what do you care about? You care about what is the input to this problem. The input is a number, right? And that number is passed as an argument, right? Which means your parameter is an integer. See, they are saying this by convention. And also, they are telling you what is the return type. Okay. So from this function, you are supposed to return a Boolean value. Why Boolean value? If the number is perfect, return true. Otherwise, return false. Okay. So now you can go ahead and start writing the code. So what do I do? First, I will try to find the factors of the given number, right? So you know that the factors of the given number, exists between 1 and the number itself, right? 1 and number itself. For instance, if you take 100, can you tell me one factor for 100 after 100? No, right? 100 is the highest factor of 100. You cannot find any more factors for n after n. So all the factors are present between 1 and the number, both inclusive. So what is our logic? So let us take f sum, that is factor sum, and let us set it to 0. So first, let's not do anything with this factor sum. So let us, for the moment, let us try to find the factors of number like this for I in range of 1 to num plus 1. Okay. So when can we say a number I, the current value, is a factor of num? We can say it's a factor if this condition holds, right? Num modulus I. Please note I is our current number and num is nothing but the given number. So for the given number, we are trying to generate all the number from 1 to that number, right? If any number in that range divides num in such way that the remainder is 0, then you can say it's a factor, right? So for the moment, I'm just printing the factor, print I, and equals the space. So I know that this will fail all the test cases. For the moment, I'm returning false because this particular function is supposed to return a Boolean value. And if I try to run this code, without returning a Boolean value, it gives me an error. So just to show you what I'm implementing step after step, okay, I'm just trying to put false for the moment. Okay, I know that test cases will fail. So let's run this and see what would be the answer. Right, cool. So you can see for the given number 28, we are successfully able to find all the factors. See 1, 2, 4, 7, 14, 28. So that's what they want us, right? But they want us to do two things. What is first one? The first one is exclude 28. The second one is sum them up. You don't really need the factors to be printed, right? Here we want it sum. So how can we do that? We can do that. First, let us see how we can exclude the given number itself. So you can exclude the given number itself by only going to num minus 1. See, just because you are going till the number, you are finding that number also as a factor, right? But if you skip it, which means if you don't travel up to the number, you won't find it as a number, right? So let's run this. And now you can see there is no 28, see? Only up to 14 we got. And take another test case. See, another test case is 7, right? For 7, only 1. So the given number is not involved, right? So this is second step. Now, you actually don't want the factors to be printed, right? You want their sum. So when a factor is found, how do you find the sum? You just add it to the f sum. F sum equal to whatever f sum was there previously plus current time. That's it. Okay. Now after coming out of the loop, print f sum. So this is also for just showing. Okay. Cool. Number is 28. What is factor sum? Factor sum is also 28. In that case, you can say it's a perfect number, right? So now how do you compare? What is the next step? After finding out the factor sum, you need to compare factor sum with the original number, right? Because according to the description, the factor sum must be equal to itself, see? So we have to compare it like this. If factor sum is equal to given number, then it's a perfect number. So return true. Perfect case. So this is perfect case. And what is not perfect case? Else return false. That's it. So if you run this code will certainly work. Okay. Now let me submit. So when I submit this code, let's see what happens. Okay. So if you are doing this in Python, there is a very big chance that you will fall into something called time limit exceeded. So what exactly is this time limit exceeded? See, every problem for this particular problem, internally the problem setters will allocate some time. So if your code is taking more than that time, then your solution is not optimal. Not optimal means it is not meeting their expectations, which means this problem can be solved within the time that they have given to you for this particular problem. Whatever the time they set, it could be 1 second or 2 seconds. The solution, if you write it optimally, should be able to pass all the test cases within the allotted time. But if your solution is taking more time than allotted, that means your solution is not optimal. So this is basically asking that, buddy, find out a better way to solve this problem. So whatever the way you are using is taking too much time. See, when they say too much time, in the context of this problem only, in the context of this problem, it can be solved better, right? So there is a reason why there is very less acceptance rate for this problem. See, out of 614K submissions, only 2.7K submissions or 275K submissions got accepted, right? The reason is there is a better way to do this. So if you use the brute force approach, it won't work. Is it clear, guys? Yeah, we can run up to num by 2 plus 1 also, but that also doesn't really save much. In terms of computers, by 2 is not that big matter. Okay, guys. So basically, this problem actually helps you know something that you already don't know, and that is to find the factors of a given number. Whatever you learned in the first year is not that great. There is a better way to do it. For instance, look, in the world of programming, there is something called as time complexity. And in the time complexity, there is a concept of worst case time complexity. And worst case time complexity will always be represented using something called as big O, right? So this is called as big O notation. So big O notation, if O of n is the time complexity, that means, this means you need to run the loop, or you need to run the loop, or you need to make the recursive calls. Both will be considered as same. Order of n means you need to run the loop, or if you are using recursion, make the recursive calls for n times, right? So what exactly does that mean? See, that means whatever you just did. For instance, to find the factors of 10, what is the logic we learned? You need to run the loop from 1 to 10 because you are generating all the numbers from 1 to 10, right? So that is nothing but running the loop from 1 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. See, for a number like 10, it's okay. You can do this, right? And for a number like something like 10 power 6, if you think about this, 10 power 6 means 1 million. And even for this, it is okay. But if it is going above 10 power 7, 10 power 8, that means even for a computer, it takes a lot of time. So to find the factors of a number that is bigger than 10 power 6 or 10 power 7, this particular program fails. Can you look at the test constraints here? See the test constraint? The number can be up to 10 power 8. That is why our logic of order of n is failing. Order of n means what? If number is 10 power 6, which means 1 million, you are running the loop up to 1 million, right? If the number is 10 power 7, 10 power 7 means 1 crore, that is 10 million, right? You are running the loop for 10 million times. So there is a better way to do it. And that better way is called as order of square root of n logic. This can be applied for factors and primes also. Okay, so first let us see how finding up the square root of n logic, how you can implement this. Okay, so first, in order to understand the square root of n logic for factors, you need to understand a simple concept. The simple concept is the factors for a number always come in pairs. Now at first glance, this kind of statement looks very silly. So what I'm saying is, for any given number, a factor never comes alone. It comes with a pair. Okay. So how about this? I will show you. Let's say we are taking 24, right? So for example, you know that 2 is a factor of 24. How do you know 2 is a factor of 24? And your answer is very simple. Sir, when I try to divide 24, with 2, the remainder is being 0, sir. That's correct. I agree to that. But the point is, if you wanna write 24 using only 2, it's not enough, right? For instance, if you're writing a 2 table, okay, and if you wanna write 24 in 2 table, you definitely have to take the help of another number, right? And what is that number? 2 into 12, right? So this is what I mean by say that factors always come in pairs. So when you are actually finding 2 is a factor, 2 is a factor because of 12, right? Because 12 into 2 is 24. That's why I'm saying that factors always come in pairs. For example, if 1 is a factor, can you tell me its pair buddy? So we generally call in terms of programming as pair buddy. Pair buddy means 1 is taking the help of another number to become a factor of 24. Can you tell me that? What is the pair buddy of 1? In the chat box. Yes. So the pair buddy of 1 is what? 24. Okay. And you know 3 is factor, right? What is the pair buddy of 3? So by taking the help of which number, 3 can multiply up to 24. 8 is the pair body. Okay, cool. Cool guys. Now 4 is a factor of 24 and it is taking the help of what? Yes, correct. It's taking the help of 6, right? Now after 4, which one is the factor of 24? After 4. After 4, 6 is the factor of 24, right? But look here guys, you can already see if you take 6 pair body is 4, right? 6 into 4 is 24. But you can see this combination is already written. 6 into 4 is already written as 4 into 6. They are same, right? So that means from this point onwards, you don't need to write anymore. 4 into 6, bus, enough. Okay. So now see, to find the factors for 24, going up to 4 is enough. Okay. Let's keep this in mind. Okay. Now, let us take 49 guys. Let's take 49. Can you tell me what are the factors of 49? What are the factors of 49? Yes, that's 1, 7 and 49, right? Now see, earlier in the way that we implemented the code, the brute force one, the order of n logic, in order to find 3 factors of 49, 1, 7 and 49, you need to travel up to where? You need to travel up to 49, from 1 to 49. But now see, if 1 is a factor of 49, what is its pair body? What is the pair body of 1? 49, right? Now, if 7 is a factor of 49, what is its pair body? 7's pair body is 7 only, right? Now, see, you don't need to go any further because after 1 and 7, you will again find 49, right? If you find 49, again the same pair will be repeated, 49 into 1. So you can stop at 7. See, for a number like 49, where did you stop? You stopped at 7. Now, can you tell me what is the relationship between 49 and 7? 7 is what? 7 is the yes. 7 is the square root of 49. Yes, 49 is the square of 7, right? So let's not confuse. 49 is square of 7, and what is the opposite of it? 7 is the, it's like passive voice and active voice, right? 7 is the square root of 40. Mathematically, it's been proven that you can find the factors of any number. So when I say factors, not only some numbers, factors of any number under its square root or up to its square root. For example, if you take 24, what is the square root of 24, guys? Square root of 24. Actually, square root of 25 is 5, right? And what is the square root of 24? It would be somewhere between 4 and 5. So which means 4.9 or something, right? So now you can see that running the loop from 1 to 4 is enough to find all the factors. See, 1 finds 24 because 1's pair body is 24 and 2's pair body is 12. 3's pair body is what? 8 and 4's pair body is 6. So these are all the factors of 24, right? See, 1, 2, 3, 4, 6, 8, 12, 20. That's it. So by running the loop from 1 till the square root of number, we can find all the factors. But now is the question. The question is, sir, if I run the loop from 1 to square root of n, okay, that's good. For example, 1 to square root of 24, right? What is square root of 24? Okay, as you said, this is 1 to 4, right, sir? Now, from 1 to 4, if I run a for loop, I can generate 1, I can generate 2, I can generate 3, I can generate 4. Good. But how can I generate when 1 is with me? How can I generate 24? When 2 is with me, how can I generate 12? When 3 is with me, how can I generate 8? When 4 is with me, how can I generate 6? Now that can be very easily understood, guys. From first standard or second standard, we are learning multiplication tables, right? For example, if you take n, you know n into 1 is n, n into 2 is some other value, and some other value, right? Now, what you can do is, you can simply write them as terms. You can write them as terms like this, x into y, or maybe a into b. If a into b is n, then you can say b can be obtained by writing n by a. Am I right or not? For instance, you know that 3 into 8. 3 into 8 is what? 24, right? Now, if you ask me a question, sir, how can I get this 8? But you can get this 8 by writing 24 by 3. Now, what is the logic here? The logic is, for a given number n, if you find that x is a factor, then n by x is also a factor. You understood, guys? So this is the logic that is very much required to understand. For a given number n, if you say x is a factor, n by x is also a factor. Now that is nothing but your pair buddy. Okay. So let me prove you that this is true. Okay. So to prove this, I am taking a number like 40. So 40 is our n, guys. Okay. And let us take x values. And let us also take n by x. N by x means given number is 40, right? 40 by x. Now, 1 is a factor, right? For every number, 1 is a factor. If x is 1, what is n by x, guys? N by x is 40 by 1, right? And 40 by 1 is what? 40. Now, same n is 40, it didn't change. Now x is 2. If x is 2, now what I'm saying, n by x is also a factor, right? N by x means 40 by 2. 40 by 2 is what? 20. Correct or not? 20 is the pair buddy, right? 2 into 20 is 40. Now what else are the factor? 5 is a factor, right? For 40, 5 is a factor. If 5 is a factor, then what? 40 by 5. What is 40 by 5? 8 is a factor. Yes or no, guys? Right? So did we miss anything in between? We missed something, right? For 40, we missed 4. If 4 is a factor, 40 by 4 is what? 40 by 4 is 10. 10 is a factor. Any more factors? Is it true, guys? Did you understood this? Any more factors, or are we missing anything, or enough? Sufficient? No. Look clearly. In this, I can say that in these 4 lines, you can find all the factors of 40. Is it true or not? Agree? Now, what's the point here? Now the point is, for any number, to find the factors, you don't actually need to go till what? Till the number. Going up to square root of number is enough. See, what is the square root of 40, guys? Can you tell me what is the square root of 40? 40 is present between 36 and 49, right? So the square root of 40 must be somewhere between 6 and 7. That is something like 6.5 maybe, or maybe 6.4. See, you didn't even go to 6, right? Going up to 5 is enough. You started from 1, 2, you checked 3. 3 is not a factor of 40, you left it. 4, 5. Is it clear, guys? So this much time we can save in terms of running. Clear? How many of you understood the logic here? Okay, so I will go ahead and I will implement this logic. So in order to show you the difference between So you will understand once you go to the square root. See, the square root logic is very simple. So just remember this. You can find factors of any number under its square root, or up until the square root of the number, you can find the factors of any number. The reason is, look, if 1 is a factor of a number, then 40 is also a factor, right? Because we studied how 1 is a factor. 1 into 40 is 40, right? 1 into 40 is 40. Okay. And if you take 2, how 2 became a factor of 40? Because 2 into 20 is 40. Now how 4 became a factor? Because 4 into 10 is a factor, right? How 5 became a factor? Because 5 into 8, right? So basically all the factors of 40 can be found within the square root. Now you may ask, sir, what about this 8, 10, 20, 40? They are not below the square root, right? But here is the catch. The factors will always come in pairs. If you find 1 as a factor, you can easily get 40 also from this. Just the formula is n by x. Okay, if 2 is a factor, just you have to think like, I have 40 with me. However, they will give you this number, right? 40 is the input, given number. And you have 2. In the for loop, you are generating 2. Now, how can I get the pair buddy? This is what you have to think. 40 is with me, 2 is with me. How can you get 20? 40 by 2, right? So basically what you are doing, if you find x is a factor, you are writing n by x. That is the pair buddy. So what are the pair buddy here? X and n by x. These are the factor pair for any number. Is it clear now? Yes. So first I will try to show you 2 implementations that proves that this actually works much faster when you are trying to code. So first let me take one program. So let's call this as demo.py. Now in this program, what I would like to do is, I would like to use 2 functions. So the first function is factor count 1. Factor count 1. Now this function takes n. This function counts factors, but it counts in a brute force way. Brute force way means uses order of n logic. Order of n logic. And the next function is define factor count 2. Okay. The factor count 2 of n also does the same thing, finds the factor count, but this uses order of square root of n logic. Now let's implement. So what is the first logic? The first logic is take factor count f equals 0 and run the loop from 1 till the number, right? So till the number, and check if any number is factor. If n mod I is 0, if it's a factor, then increment factor count. And finally, print factor. This is good, right? So let's write an f string here. An f string state that factors of n are, right? So let's say number of factors. Number of factors of n are LC. So that is the factor count, right? Cool. Yeah. Now let's do the same thing, but this time let us use the square root logic. Okay. So let's use the square root logic. Now in the square root logic, I don't go up to n. I will go up to square root of n, right? So to go till square root of n, I'm using the math module. So that is import math in Python. If you are using Java, you need to write math.square root. If you are using C++, you can use sqrt, right? So I need to find the square root of n. So that is math.square root of n. But square root of n comes in point values, right? We don't need point values because range function only works on integers in Python. So let's convert that into integer. And we need to visit the square root of the number also, right? The reason is, look here, for a number like 7, 49. What is the other factor? 7, right? So that is exactly the square root. So we should not exclude square root. We need to include square root. So I'm writing plus 1, right? So this will be finding the square root and we'll be adding 1 to it. So till the square root of number I'm going. And now what I'm checking is, if n mod I is 0, this is the pointers. If n mod I is 0, I'm not writing fc plus c equal to 1. I'm writing fc plus c equal to 2. Now I need you to tell me in the chat box, why am I writing factor count plus c equal to 2? You got the point? So I am not incrementing the factor count by 1. I'm incrementing by 2. Why? Yes, you got it. Now you got it. The reason is, see, that's what we discussed so far, right? You are never ever finding out one factor. Keep this in mind, guys. When you are trying to find the factors, you are always finding 2. You just don't see the other one, right? So you're not just finding 1, you're finding 40 also. You're not just finding 2, you're finding 20 also. Not just finding 4, you're finding 10 also. So that's why every time I'm finding 2 factors. Okay. Now let's try to call these 2 functions with the values. So first let's try to call the first function, factor count 1. Let's call with this 10. Okay. And let's call factor count 2 also with 10. Let's see what it will print. So let me run this code. See, both of them are working, right? So it seems like there is no problem at all for number like 10. For number like 10, the first logic is giving output as fast as the second, right? But this is the point, guys. You need to think in terms of bigger numbers. What if I feed a number like 10 power 8? Will it give the same answer in the same way? Let us check. Okay. So what is 10 power 8? 10 power 8 is 10 followed by 8 zeros, right? So let's pick 10 power 7 only. 10 power 8 is also not needed. So 1, 2, 3, 4, 5, 6, 7. Okay, let's count the zeros. 1, 2, 3, 4, 5, 6, 7, right? So when I try to execute this, guys, just observe what is happening in the console. Okay. In the terminal, see what it is giving. Number of factors for 1, 2, 3, 4, 5, 6, 7 are 64, but it took some time to get that answer, right? So if you increase by 1 more 0, see how much time it will take. So let me put it side. Let me run this. So you can see here, guys, in the console. So I will show you again. In the console, see, it's calculating. It's not giving answer. Look here. It will give now. See, 80. Now, what you can do is you can feed the same number. Let us copy this. Let's feed the same number to this function and comment this one. Now see, for this code, how quickly the output comes. Okay. So just see for how quickly the output comes. 3, 2, 1, go. See. But wait a minute. Did you see any difference in the outputs? So let me show you again. Okay. So let me show you. Let me run this. When I run this, one logic is taking more time than the other. That's obvious. But you can see the second code is giving 82 as answer, as the first one is giving only 81. Can you tell me what could be the reason for it? Why this is happening? Okay, listen everyone, guys. Okay, listen, carefully listen. Actually, this logic saves the time, but it actually comes with a simple twist in it. And that twist you need to understand. And this twist only happens for perfect squares. So the logic can give you wrong answer for perfect squares, right? Now, the reason it gives wrong answer for perfect squares, you will understand it now. See, for instance, if you take a number like 24, for a number like 24, everything is looking good, right? For instance, 1 into 24, different numbers. 1 is different number, 24 is different. 2 into 12, 2 different numbers. 3 into 8, 2 different numbers. 4 into 6, 2 different numbers, right? But can you tell me what is the answer for 100? For example, 100, 1, 100. This is one pair, right? 2, 50, another. 3, and then what? 3 is not a factor at all, right? 4, and then 25. Another pair. What is the next pair? After 4 and 25. For 100, can you tell me for 100 what is the next pair after 4 and 25? 5 and 520. Okay, correct. Now what is the next pair? This is the crucial point. What is the next pair? That's 10 and 10, right? Now 10 and 10, are they two different numbers or same number? Same, right? Now in our logic, we didn't check this, right? We didn't check this and we are counting 10 for 2 times. Now this problem, guys, it only happens for perfect squares. Perfect squares means, take 36 for example. 36 is 6 square, right? See, 1 and 36, this is one pair. 2 and 18 is another pair. 3 and 12 is another pair. And what is the next pair? 4 and 9 is another pair. 4 9 is 36. The next pair is 6 and 6. 6 6 is 36, right? Now, I have a question for you. How do you tackle this case? How do you make that one extra number disappear? Because we are counting 2 times, right? This is not correct. It's very easy, guys. Look, it's very easy. Just how you can do this is, see, we know about pair buddies, right? What did we talk about pair buddies? If x is a value, then n by x is pair buddy, right? Now you can see in all cases, x and n by x are different. 136. So you can say it's pair. 218 pair. 312 pair. 49 different pair. But you can see 6 and 6 same. So you can easily check whether x and n by x are equal or not. If they are equal, that means you need to count only once. Only one number is there. If they are not equal, you don't need to count. You can count 2 times. Understood, guys? So what is the change we are going to make this code? See, if the factor is found, we are not directly incrementing the factor count. Okay, so let's note that. Instead of doing that, what we are doing, we are checking if x, which means I here in this case, is equal to n by I. If it is equal to n by I, that means you should only count for once. Fc plus equal to 1. Otherwise, you can count 2 times. So you guys understood the point? If it's a factor, okay, cool, it's a factor. But what I'm checking is, are the pair buddies same? Pair buddies same means 1 and n by I are the same. If they are same, then there is only one number. You have to count once. Otherwise, you need to count twice. So shall we run this now? So when you run it now both the logics will give 81. See? Is it understood, guys? Square root logic. But what is the point here? The point is, see how fast it is given. Okay. So when you run this, please observe that it's giving in split second. See, running this, there you go. And you can clearly observe the difference for this number. See, the previous logic, this one, see how much time it is taking. There is no answer yet. Now it came. Guys, you understood this one? How many of you understood this square root logic? So I'm putting this in the chat box, okay? So if you want, you can use that code and you can convert it into language of your choice. Okay, guys. Now using this logic, what we will try to do is, we will try to find the factor sum. Okay. So let's go to the perfect number problem. So what we can try to do is, we can slightly change our logic. So we don't want to go till num, but where do we go? We will go up to square root of num, right? So let's write math.square root of num. But since square root comes in float value, we will convert that into integer and we will include that one also. 1, if num mod I is 0, so what do we do? So first we will check if pair buddy I and num by I, if they are same, then factor sum. For factor sum, I will add I for once. Otherwise, I will add 2 things. Factor sum plus equal to I, factor sum plus equal to n by I. Got it, guys? So 2 factors, right? We should not forget. One factor is I, another factor is num by I. Both of them are being added to factor sum. Now what I will check is factor sum minus num. See, I am checking minus num because there is one reason that I am also adding number. the given number, right? Because see, when 1 is factor, you know it, right? When 1 is factor, the number itself is factor, right? So in that case, I'm adding number also. So first I'm subtracting that extra time and then I'm comparing with number. Okay, there is no something very tricky here. The point is, in this logic, I'm not only adding up to the number of factors minus 1, right? I'm also adding the given number, right? So to counter that, I'm subtracting, right? Or also you can check if the epsum minus num equal to 0, right? Like because you were adding this for one extra time, right? So anyways, so I'm going to run this and still it should give the test cases passed. So these two are passed. Now when you run submit this, you don't get any TI. Okay, let us see this. Accepted. Guys, you understood how we were able to counter the TI? So this is very fundamental, guys, and this will be useful to you in a lot of places. So even if you, I guess in GFG, if you take a prime program, so this prime program will also be medium because of this reason. Let me see if I can practice coding problems. Is there a site for this GFG gigs per gig? So we got explore, right? Yeah. Explore.
క్లాస్ లో ఉన్నాను.
Search for something like prime.
పెట్టే
Prime or so I can't find this problem right now. So once I found this problem, I will share it in the group. Okay. So this is similar to factors only, finding out the factor count or factor sum, such type of a problem. But this requires you to know this logic. Okay. Without knowing this logic, you can't solve the problem. Is it clear, guys? Okay. Cool. So you guys said that a lot of you said that you are very familiar with the problems that deal with the digits of a given number, right? So can you reassure that? Which means, is it true? So will you be able to solve the problems that almost like asks you on digits of a given number, find the sum of digits like that? Yes? Okay, then so I'm sending you 3 problems from LeetCode, which are very fundamental and asks you simplest of the operations on digits. Okay, they will ask you to do some operations on digits. So before coming to tomorrow's class, just do them. So tomorrow we will see the solutions for them, and then we will switch to concepts like arrays. Of course, in tomorrow's class, we will also see the prime, how you can find whether the given number is prime or not using the same logic. Same logic means today we learned the square root logic for factors, right? Actually, it can be leveraged and used to find whether the given number is prime or not also under order of square root of n. Okay, so that is the best you can get for primes and factors, give or take. Clear, guys? So the problems are in the chat box. All the 3 problems from LeetCode, I'm pretty sure that you won't even take 15 minutes to solve all of them, right? So very fundamental, just have a look at them and try to solve at least one of them. We will see them tomorrow. We will see more problems. I told you, right? So we have to keep it a habit, like at least solving 1 or 2 problems just to keep our knowledge on programming intact, right? All right, guys. So that's it from my side for the day. So thank you for joining the session. I hope you understood it. So if you have no more doubts, you can actually leave the session. So if you have any doubts, you can put up in the chat box as usual. Good night, guys.
కనబడదా?
ల్యాప్టాప్ అలాగే ఇట్టావా
ఏ బాబోయ్ 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 అయిపోయింది, అనర్థం జరిగిపోయింది. బాబోయ్ బాబోయ్ జాగ్రత్తలు జాగ్రత్తలు. ఏమైంది నా మీద ఉంటుంది కదా, ఇది ఎందుకు ఉండదు?
Okay, for the moment, I am not recording the classes. Maybe I will try to record them from tomorrow.
చూసే వెళ్ళారు.
Yeah, I'll try to record it from tomorrow. So I'm already telling you this, guys. If you feel like this class is going on in a direction that you already explored, definitely you don't belong here. Your skills set is much higher than this. So you can go to the advanced coding classes. Okay, so this is how it will start here, but I can guarantee you that over the period I will take you to problems that could be considered as intermediate level and even slightly advanced, but not right away. It's going to take some time, say 2 to 3 months time. Okay, guys, thank you. So for those who are actually in the class but not listening because you are not leaving here, I really hope that even though you joined the class for attendance sake, I really hope you are using this 1 hour in a way that is very productive for you, right? So it's